Good afternoon, Randa. In the today's session, we'd like to discuss regarding the different machining methods that are used for gear manufacturing in the shaping process. As we already discussed, the shaping in the sense getting the required dimensions by progressing the different kinds of methods, processing methods, which we usually utilize either in cold working confinement or else the hard working processes. In the today's session, we'd like to discuss the machining methods, different kinds of machining methods which are utilized particularly for gear manufacturing process. As we have been discussed in yesterday's class, different casting methods, cold working methods, pressurizer methods, for manufacturing of the gears, had a detailed vision or glance over it. In advance to that, the typical methods utilized for manufacturing the gears for getting the full furnishings as per the required charts, or we'll be calling the vendor's requirement drawings. Coming to the machining methods, we're having different methods or different routes, different directions for machining the gears. Initially, the blanks are performed and those are machined, and then they are finished properly. After that, the teeth are produced by the cutting processes which are used in our machining areas such as milling machines, lathe working machines, arranging machines plays a major role for getting the teeth confidities. Basically, these are produced only on the rotational basis of works by fixing either by fixing the work part within the machinery and performing the rotational work by the tool over the work part, or the work part will be rotated and the tool will be in fixed position for getting energized the task of getting this tooth in the diametrical axis of the work part. Almost all full gears with the designed document that number of teeth should be accessed with respect to particular proforma, a particular profile, particular diameter consistent should be maintained, and tooth thickness and those are manufactured by different process, and later on that they have finished by the machining process, such as a finishing process or else the grinding process, by the grounding process. Particularly the accuracy as per the vendor's drawings will be achieved by near net shape processes. So near net shape process. Similarly, like the rolling process that will be utilizing for getting the particular diameter of the objects after the processing. Plastic molding process, indeed to get the particular shape, that too with the fixed dimensions after getting the machinery work done over the objects. Powder metallurgy, as you have been seen in the sand casting process, particular material should be taken and it has to be blended and the heat source should be utilized. Here, no further finishing is required in this process of finishing the gas. But generally, widely utilizing method in the zone is the performing of blank initially by casting process. Next, application of the pressure for getting the prescribed shapes, such as a forging concepts, transforming the generated shapes to the required shapes by forming process. And for these blank designs of different dimensions, producing of this teeth by different machining processes are done either by the milling process or else by the arranging processes or different means of cutting processes which are suitable for getting the desired profile of the tooth or its diametrical range of the gas by maintaining a particular thickness and depth, sharpness, tips, and later on the finishing processes getting done over it for removing the rough surface finishings. And that is done by either by the finishing process or else by the grinding processes if at all it is necessary. Majorly, we are having two different methods for getting the gear tooth as per the desired geometry or the work parts. First one is the forming process and next one is the generation process. Forming process is casually called as the form cutting process also. In this, the profile of tooth is obtained or obtained as the replica of the form of cutting by the tooth. Normally, as we'll be seeing the machining process of removing of the material as per the required shapes as the mating, this the cutter will be utilizing and the mating process is getting done over the blank gear as per the design criteria to be maintained at the addendum, dedendum, at the addendum point of view and the dedendum point of view, and maintaining the uh, flute angle with respect to the tooth. This process by in the real-time basis is monitored over the milling machine or else the broaching, and even the shear cutting process or else the teeth cutting process will be falling with the different names for getting the accurate profile range of the tooth. Basically, the cutting edge of the tool is having a shape that is identical with the shape of the space between that particular gear. As the mating here clearly specifies that the concave nature was directly depending in order to get the convex shapes over the objects and the particular depth of the objects up to the gear profile to be maintained. For exact maintenance of the dedendum circle, and this is the addendum range of the circle, and this is the dedendum range of the circle, was perfectly maintained for getting the shapes throughout the circumference of the gap. This is also called as the copying or profiling methods. Second thing it is, second method of getting the tooth is the generating process. Normally, in this process, in the forming process, the minimal range of the tooth profiles are prepared very much easily, but in the complicated type of tooth, by maintaining with respect to the different range of its circumferential ranges of the tooths, generally we should use it to call as this complicated tooth profiles. These are processed by the edges of the cutting tool by the rolling type of process, or else by the tool work motions over the work part, such as the hobbing process, a gear shaping process, etc. Nominally, these are characterized by automatic indexing and the ability of a single cutter, you know, that is to be used for cutting the gears for the required number of the teeth in the combination of a given module and the pressure of the inclinations to be specified. Generally, the term generating refers to the shape of the gear tooth that results as not the conjugate form of the cutting tool. Even if the shape of the tooth is generated by the combined motions of this workpiece in the cutting tool, the results that will be getting generated, that it's not the conjugate form of the cutting tool. That's the generating form of manufacturing the gas, and its profile arranges in between the addendum and dedendum circles of the external range of the diameters of the objects. Gear forming by the machining process. How the gear will be getting formed, we'll be discussing by the machining, one of the machining process. So we'll be utilizing this milling process, the machining process for manufacturing of the gas for the desired profile range is the gear milling process. Normally, this gear milling process involves two methods of cutting processes. First one is the milling cutters, and second one is the end mill cutter. So the cutting tool will be getting varied and its functionalities will be getting different. But finally, the representation or shapes of the gears during the manufacturing will be getting the similar. Coming to the disc cutter, the disc cutter shape, it conformsly get the gear tooth space, and for each and every gear cutter, it needs to be get a separate cutter range. Nominally, for example, 8 to 10 standard cutters or gears from 12 to 120 teeth can be cut. That too with a better accuracy range maintaining by maintaining the perfect accuracy as per the statistical data or drawing as per the drawing. Here, the tooth is shaped by the cutting process at each and every range by one by plunging the cutter, rotating cutter into the blank or an ideal range of diametric object. And we'll be achieving the n number of tooth that are required throughout its circumference or towards its diameter of the gap. So in this, the cutter will be in a fixed strategy, and on the working basis, it will be getting measured with respect to the cutter and the work part by maintaining a particular feed, speed, and a depth of cut. From the addendum range, this is the addendum range, outermost part of the diameter of the object, and towards the dedendum, that's an bottom range of the gear cutter up to the depth of the gear mating within the tooth as represented within the diagrammatical verses. Here in the case of this disc cutter, the tool is fixed in range and work part will be getting monitored as per the jigs and fixtures. It will be getting varied and the work will be getting done. In the case of this end mill cutter process, the shape initially it conforms to the tooth spacing, but here also maintains the same strategy that cutting of the tooth is done at a time and is indexed for the next tooth spacing either by cutting process and usually get from 12 to 120 teeth gas, but similarly equivalent to the disc cutters. But this end mill cutter is suited for small volume of production, that too for getting the low precision gears, but not the perfect dimensions. The perfectness with great accuracy will be getting asked by the machining process in the disc cutter itself, in the milling process. But here in the hand milling process, the precision will be getting lowered by the palm milling, that is by hand mill cutter, as it clearly initiates in the diagram. In order to reduce the economical criteria, the same gear is utilized multiple number of times for manufacturing multiple sized gears that used to result in profile errors, getting the profile errors between one tooth to the another tooth. Majorly, in the case of this farm milling method, we used to get the less deviations in the manufacturing range. Nothing but even the rough conditions also will be getting reduced. But in the case of this end milling process, we used to observe a greater deflections in the manufacturing regions for getting the gear tooth up to a prescribed dimensions. Hence, we can clearly conclude that the disc cutter or form milling process, in the form milling process, disc cutter mechanism is best suited for the manufacturing of gear profiles, that too with an accurate range. But in the case of this end mill cutter, in the form milling process, it leads to the dimensional changes during the gear manufacturing or gear tooth manufacturing. Coming to the characteristics of this gear milling process. Normally, we will be utilizing this high-speed steel mill cutters for the progress of the milling, and typically utilizing only the ordinary machines for commencement of the work and getting the precision oriented results over the work parts after getting machined either by the end milling process or by the nominal form milling process. Getting the low production rate, which is having slow speed and feed rates, need of indexing after machining each tooth gap. Coming to the basic phenomena, the gears which are having different modules, and obviously it will changes the number of tooth that are needed for separating the mill cutters. So this better suits in range in the machining process. This milling process, gear milling process, best suits the manufacturing process of the gears, that too in a less economical factor when compared to the hops range of manufacturing. But when compared to the hops, this gear milling process will be having less accuracy and even less surface finish when it has been compared to the hop system. And even there is an inventory problem because in order to get a set of 8 cutters for each and every module, we're maintaining a pressure angle combination with the maintenance of this pressure angle combination. There's a slight deviational errors that will be occurred. Always tends to change the order conventions and fixing of the cutters is necessary. And nominally, we'll be calling this always changes as an inventory problems. Even this disc cutters are utilized for a big spur gears, which of having large pitch diameters. Nominally, end mill cutters, which are used or preferable for teeth of large gears or modules. Let's have a detailed discussion regarding the indexing and farm milling process. In the farm milling, indexing of a gear, gear blank, indexing is nothing but the fixation or else the maintenance for getting the manufacturing or for getting the gears to be prepared over the machinery. Finally, we'll be calling this as a production of teeth over the blank gears. Blank gears. Indexing is the process of evenly dividing the circumference of the gear blank into equally spaced divisions throughout its circumference. Particularly, this index head is utilized for fixing the number of tooth that divides equally over the work part throughout its circumference range. As represented in the diagram, it consists of an index fixture, consists of an index head, which is dividing its head, gear cutter attachments, as shown in the picture number 2, and having its footstock, which is similar to the tailstock of the lathe as represented in the diagram. This index head and the footstock attached to the work table of the milling machine, and index plate, which is containing a graduations, is used to control the rotation of this index head spindle, and these gear blanks are held between the centers, nominally as represented in the diagrams, held in the centers. Particularly, which has been supposed by its index head spindle and the footstock. And even the workpiece is also fixed in the chunks at the index and head positions, which we use it to examine by the tailstocks and verify its circumference by the fixation of its positions throughout its circumference. By this, we'll be getting the equivalent number of tools by maintaining the perfect profile dimensions throughout its circumference, and commonly asked conditions during the machining process will be succeeded. Secondly, by the shaping process, tooth attaining by the shaping process, planing machines and slotting machines. So shaping is nothing but transferring of the dimensions from the original shape to the required shapes, that to a plastical range, plasticity of range. So we all know that plasticity of range in this is nothing but permanent changes in the dimensions are achieved after getting the work commencement. In the shaper machines, either it may be of the sub-supporting machines such as planing machines, slotting machines, reaming process, whatsoever it may be. Normally, it leads to act as a sliding positions, nothing but we'll be calling as some to and fro motions, as like that of reciprocating actions. When the fixed consignment up to a particular length, it will be getting worked out. So reciprocation actions or to and fro motions will be getting taken place, which usually called as a linear motion of cutting. Generally used to cut as called as this linear motion of cutting process and getting the shape as per the requirement. As the tool that reciprocates over the blank of the gear, we used to get the cuts throughout its process, and the work part will be getting rotated at a fixed axis of its rotations. Nothing but a blank will be fixed over it, and at a fixed consignment, the revolutionary concept will be getting taken place, and the tool will be getting monitored over the work part in the sliding motions. Particularly in the case of this shapening, by changing of the slight angle will be achieving the pitch of the teeth until and unless all the tooth has been cut throughout its circumference. In shaping, both the productivity and product quality are very less, and that too used for repair and maintenance purpose only. So after getting usually called as a reboring concept, it's best suited for this method of shaping or planing or slotting, is best suited for only the reboring type of accessories, reboring type of concept. And having just like some maintenance session. Here, parallelly, a multiple shaping of the tooth gaps are made simultaneously without having any indexing capability throughout its radial circumference by giving a particular feeding by only a single point, and can have the highest range of work ability. For commencement of this task or fixation of this type of environment to be commenced by the machinery, it's highly economical in range, getting highest initial cost for the installation of the machinery, and running costs also plus a major role, and skillful work is necessary for operating over that particular machinery without getting any dimensional deviances, because the entire object will be getting deteriorated if at all any commencement has been taken place over the object by the tool. Generally, in the planing and slotting machine works, these two works on the similar principle. Nominally, this planing machine for large gears will be utilizing, and whereas the slotting generally used for internal gears for getting often a low depth of cuts. Coming to the broaching point of view, it's a multi-toothed tool as represented in the diagram. It's a multi-toothed tool which is utilized for getting the small cut representations simultaneously when all the teeth have passed over the gear blank in order to machine the required amount of the material that has to be removed, and gear teeth are shaped with the necessary document, nothing but desired dimensions with preferred accuracy or greater accuracy. Normally, these situations of spare of this gear teeth is used to form the broach teeth, form of the broach teeth, used for the teeth of small internal and external spur gears. Even in order to form these helical gears, the two straight or single helical gears, which are relatively softer materials on the produced in softer materials, but in larger quantity, as an internal gears, racks, splines, and the sector gears. Hence, we can conclude the greatest point that external tooth are produced by broaching only at a single pass, but only the one pass of the tool or the entire diametrical object. Hence, we can declare that high productivity, very high productivity with a great quality can be achieved by this broaching machinery, broaching working process. But the installation cost or cost of the machinery and operating economy is very much high. The gear generation with an point and point to spaces will be discussing in the next class. Thank you.